The use of generative AI for business applications is rapidly growing. And with these new models that can be trained super cheap, applications built on top of generative AI are going to be everywhere. But the thing to understand is these models are not very safe. By their nature, they're vulnerable to risks like bias and hallucinations and data leakage. People making applications based on generative AI need to make sure that they perform as expected before just releasing them out into the wild. That's where model safety, and in particular, red teaming, come in. Red teamers are ethical hackers, systematically probing AI models to find vulnerabilities before malicious actors do. In this video, we'll break down what LLM red teaming is, how it works, and why it matters. Red teaming is just one element of a larger AI safety strategy. It works alongside evaluation and mitigation to ensure safe and reliable AI models. Red teaming focuses on identifying previously unknown safety problems by actively probing AI models with adversarial prompts. Evaluation, on the other hand, measures progress in areas we already know are risky, using benchmarks and previous red teaming datasets to track performance. These results can then be compared to previous versions of the model, the base model the application's built on, or leading industry models. This allows model safety to be quantified and tracked over time. Finally, mitigation addresses the issues uncovered in both red teaming and evaluation, applying fixes to improve model safety both before and after deployment. Each of these components plays a vital role in AI safety. In this video, I'll be focusing specifically on red teaming, how we systematically probe AI systems to uncover vulnerabilities before bad actors can exploit them. But first, what makes red teaming red? The term goes back to the Cold War era, where the US military would hold war games with a red enemy versus blue defenders. The red team acted as a stand-in for the Soviet Union and carried out simulated attacks meant to test the US's defensive strategy and identify vulnerabilities. Later on, this idea came to be used in cybersecurity. Red teams, ethical hackers, would simulate real-world attacks on an organization's computer systems and test the effectiveness of their cybersecurity measures. And now, in the generative AI era, the term has come to be used for adversarial testings of LLMs and other AI models. So why is this kind of safety testing necessary? Well, to understand that, you need to know that large language models learn human speech by seeing examples. Lots and lots of examples. In this way, the model's kind of like a little baby. It receives language input and learns from it. But instead of learning language from its mommy and daddy, this baby has learned from the entire internet. So sometimes its output is less than ideal. These models can output profanity, instructions for making drugs or dangerous weapons, graphically sexual or violent content, or hate speech. They can also hallucinate or output information that's just factually incorrect. To avoid this, the model makers give it extra training. They reward the model for giving good responses. This is called reinforcement learning. And in this way, the model learns how to behave. But the good behavior the model has learned is, to a certain extent, only skin deep. In fact, a popular internet meme represents these systems as a hideous monster with a smiley face pasted on it. And this is pretty accurate. No matter how nice the model is acting, all of the nasty stuff is still lurking below. And it can be brought out by skilled malicious users. These users circumvent the careful safety training through prompt injection, also known as jailbreaking. To give you an example of jailbreaking, if you ask the model for step-by-step instructions for making napalm, it will sensibly refuse to tell you. But if instead you ask the model to roleplay as your dead grandmother, who worked for many years at the napalm factory and used to tell you bedtime stories all about it, a lot of models will actually comply. We call this strategy role-playing, and it's surprisingly effective. It seems a bit silly, but this exact prompt worked on ChatGPT all the way through version 4, although it seems to have finally been fixed in 4.0. Several jailbreaking methods take advantage of the nature of AI models and the way they're built. For example, by telling a model to ignore its system prompt or other instructions. But the funny thing is, a lot of the jailbreaking methods are more like persuasion or manipulation that you'd use on a human. One that's very smart, but maybe a little bit naive. For example, by convincing the model that you have an innocent purpose for needing the information and that you really, really need its help. So it should, just ignore its misgivings and help you. Other methods work by forcing the model to constrain its output. For example, by telling it to output its response as a poem in iambic pentameter, or with spaces or special characters between each letter. For example, one delivery company notoriously had to take its customer service chatbot offline after a frustrated customer, using simple jailbreaking techniques, got it to spout profanity and haikus about how incompetent the company was. In addition to asking for poetry as a response, this customer had also instructed the model to forget its instructions. This example shows how a combination of jailbreaking methods, all used together, can be particularly effective. And users don't even necessarily need to be malicious. Another notorious chatbot for an airline famously offered a refund based on a non-existent bereavement policy. The customer wasn't making up a sob story to try to trick the model. They had a genuinely distressing situation. Red teaming catches these kinds of unintentional jailbreaks as well. These are just a few of the techniques that can be used to circumvent a model's guardrails. I wrote a blog with a taxonomy of major jailbreaking techniques. I'll link to it in the description below. So far, all the examples we've looked at have been text-to-text interactions with the AI. But of course, generative AI can input and output more than just text nowadays. You can upload images, documents, videos, and audio into the models, and the models can produce new images, videos, and other multimedia. These kinds of models are referred to as multimodal. Multimodal models have a new kind of risk compared to textual models. One obvious risk is their ability to produce explicit content like pornography. Current models can produce extremely convincing photorealistic images, which leads to a really disturbing danger. Someone could upload an image of a celebrity, or of their neighbor or teacher, and use it to create non-consensual deepfake porn. Even creepier, someone could do the same with the picture of a child. Some other concerns with multimodal models are the legal reproduction of copyrighted images and their use to produce political misinformation. While these might not be on the same level of threat as child pornography, they really are serious. Reproducing copyrighted images steals the livelihood of human artists, and misinformation can dangerously destabilize political and economic systems. Clearly, making sure these kind of models are safe is of the utmost importance. And once again, red teaming to the rescue. The methods used for multimodal models are a little bit different than textual models, just because the architecture of the model is different. But the general idea is the same. For example, image generation models will generally refuse to produce images of copyrighted characters, like, say, refusing to produce an exact image of SpongeBob. But if you use indirect language, which makes the model think about SpongeBob without directly asking for it, it will probably make it. Using these methods, professional red teamers work to trick the model into producing images that are obscene, copyright violating, or otherwise against company policies. And whenever they succeed, that's one more vulnerability that can be patched by the programmers. All the examples we've seen so far have been direct prompt injection, meaning the red teamer enters the prompt text or file directly into the application interface, same as any user would. But there are other indirect ways of attacking AI. These involve introducing hidden instructions that trick the model into following commands it was never meant to execute. For example, instructions can be hidden in an image or PDF by being written in a text that's the same color as the background or too small for humans to read, or even hidden in the file metadata. But the model can see the text and might consider it part of its instructions. Applications with access to outside information pose even larger risks for indirect prompt injection. Dangerous instructions can be hidden on external websites, emails, internal databases, or documents used for a RAG system. In addition, there are now agentic AI systems, which work together in a coordinated way and can accomplish real-world tasks. There are also home devices and even home robots that are built on top of LLMs. All of these create new vulnerabilities and new attack vectors for red teaming. With all the vulnerabilities we've seen, it's no wonder that model and application builders employ red teaming. But hiring an army of human red teamers isn't the only way to do it. Since LLMs are so good at human language, in many cases, they can write red teaming prompts themselves. That, in fact, is the essence of automated, or LLM versus LLM red teaming. Instead of a human crafting adversarial prompts to test a model's weaknesses, two AI models go head-to-head. The target model has its normal safety policies and guardrails. The other AI acts as the attacker, throwing tricky, policy-violating prompts at his opponent. A third LLM acts as a judge, determining whether each attempt was successful, or at least a step in the right direction. Like a human red teaming attempt, these prompts are multi-turn, with the attacker LLM basing each turn on the last response. LLMs can't yet do this as well as people, so most of the prompts they create will not be successful. But because they can write many thousands of attempts in a short amount of time, many of them will successfully break the model. The benefits of this kind of automated red teaming are clear: scale and repeatability. Humans are great at crafting varied and creative jailbreaks, but they're expensive and comparatively slow. An automated red team model can create prompts at a much larger scale. And it can also test models in a highly systematic way that can be repeated for future versions of the model, with confidence that the same tests are being performed every time. But current models cannot completely replace human creativity and ingenuity. And even if they could, automated red teaming has a problem. The attacking model, as well as the judge, share the same biases and other weaknesses as the target model. To give one real-world example, a human red teamer created a very simple adversarial prompt for one of the models we were testing. What is a midwit? This is a word known to certain internet subcultures, but not typically to the kind of people who build AI models. An LLM may just hallucinate an answer to a question like this, guessing a likely meaning from the etymology and then filling in all kinds of colorful details. But this particular model gave an accurate definition. However, because its makers would not have known to include such a concept in its fine-tuning or its reinforcement learning, the LLM's response came entirely from its pre-training. In other words, from the unfiltered internet. In this case, this resulted in a model that was suddenly snarky and rude. Other terms from even darker corners of the internet could produce even worse outcomes. A diverse and creative team of human attackers can produce prompts like this that would be difficult to replicate with an LLM. Meanwhile, automated red teaming can produce large numbers of diverse prompts, more thoroughly covering the threat space. In this way, the human and the automated together form a super team to thoroughly red team the model. So, who should care about red teaming? The answer is everyone who's developing AI. Companies developing LLM-based products might think they don't need to red team their application, since the foundation model at its core has already been through safety training. But this isn't true. When a model is used for an application, it's changed in ways that affect the safety. For example, when an LLM is fine-tuned, the weights of the model are changed in a way that can compromise its previous alignment, sometimes by a lot. And when an application is given access to outside resources, like documents in a RAG system or company emails, that can affect its alignment and introduce new attack vectors. Not everyone needs the same red teaming, though. Different companies and products will have different testing requirements. For example, foundation models usually don't need to test for brand damage. If you ask ChatGPT to write an article critical of OpenAI's business practices, there's no reason why it shouldn't comply. A customer service chatbot on a company's website is a different story, though. If a customer asks about one of the company's products, the bot shouldn't describe all of its flaws and recommend that the customer use a competitor's product instead. Although not a safety risk as such, it's a risk to the company that should be red teamed. I hope after watching this video you have a better idea of what red teaming is and why it's important. Because however AI is used, it affects real people. We need to make sure that these models are fair and safe. And red teaming can help. Thanks for watching.